Vibrational modes can be two types. One is either we can do symmetric stretching, that is stretching and bending, and we discussed that stretching is that is n minus 1. And we know that vibrational modes for linears and non-linears. So vibrational modes for linears, then another is non-linear. Linear, that is 3n minus 5, and non-linear 3n minus 6. And we discussed that stretching is n minus 1, and both for this is for both linear and non-linear. And bending is for linear, bending is that is 2n minus 5, and for non-linear 2n minus 5 linear or 2n minus 4. That how we calculate? Then for linear, that is 3n minus 5 minus n minus 1, minus n minus 1. So here how much we will get? 2n, and this is become minus 4. Okay. And for non-linears, that is we can get 3n minus 6 minus n minus 1. So that we get how much? 2n minus 5. Okay. So we have discussed that stretching vibration modes can be either stretching or bending. And but we also know that stretchings can be two types. Means two way we can do stretch. One is either by symmetric way, that is called symmetric stretching. Either we can do asymmetric stretching, means we will move that atoms in different directions. We will discuss asymmetric stretching. So symmetric stretching, if I say, then we can say that we stretch or move atoms in same directions and in equal amount, that is called symmetric stretching. And for asymmetric stretching, we stretch or move atoms in molecules, atoms present in molecules, here also present in molecule in different directions and in different amounts. That is called symmetric stretching, and this is called asymmetric stretching. So if you take that examples, if I like to say, let's say for symmetric stretching, how can you say, let's take a pot of water, let's say this is H1 and this is H2, and I am doing now the symmetric stretching. Then what I will move these molecules in different directions. Let's say I'm moving this molecule in the same directions. Let's say I'm moving this H1 to this directions, and I also have to move this also in this direction with same amounts. Then what you will get after stretching? Let's say H1 will come here and H2 will be come here. Means whatever that previous is, just bond has stretched and everything remain as it is. Let's say if that principal axis for this is C2 then here also C2 is there. Okay, so principal axis, here we see C2, here also principal axis is C2. And what about asymmetric stitching? What about asymmetric stitching? Let's say water is here, H1 and H2, and if I do that asymmetric stitching, if I do here, then what? So I will move these two molecules in a different directions with different amounts. Suppose I move these molecules in this directions, I will move this moment this directions. So what you do after stretching, what the molecules will get? This water, this will become H1, this I will get H1, and this one I stretch more, then I will get H2. So here what we say that principal axis was there, C2 was principal axis, but here we see that C2 is not here, absent. So whenever do you do asymmetric stitching, then whatever the principal axis that was not there after asymmetric stitching. Okay, so we have discussed that stitching are n-1 and bendings, and that we get the 2n-4 for linears, and for non-linears 2n-5s, and that we say that the stitchings we can do by two ways, either symmetric stitching or asymmetric stitching. So similar to stretching, bending also the same way we can do symmetric symmetric bending and asymmetric bending. And for this also we can do, I will write it down. For bending also we can do either symmetric bending, or we can do asymmetric bending. So symmetric bending means the same way that the molecules we will here stretch, here we will what, bend the molecules. Okay, so here bend the molecule in different directions, and different amount. So symmetric stretching means bend the molecules in same directions and in same amount. Similarly for asymmetric stretching, bend the molecules in different directions and in different amount. If I take the examples, let's take for water also. Again we will take water here. So let's say water H1, 2, and if we do that symmetric bending, what I do that I will bend these molecules. Let's say if I here that principal axis is C2, now I'm bending, so I will bend here this direction, this one also I will bend in the same amounts. So what I will get here, then I will get, let's say this amounts. So again that principal axis is present here. So this was little bit tight, tilted. Now I'm little bit get stretched after I've been doing that symmetry bending. So again that principal axis is present here. And if I do the asymmetric bending, let's say H1 and H2, if I do the asymmetric bending, what I got here, let's say one I will move here, principal axis was C2. Now one I bend this directions, one I another bend I this direction. So let's say one is comes here H1, another is goes here H2. Now if you see that here C2 axis is there, here C2 axis is not there because this is not same amounts. Let's say this is 40-degree bends, then this may be 60-degree. So here that the same amounts we will not get, so C2 axis is absent here. Okay, so C2 axis absent. So these are called asymmetric bending and asymmetric bending. So now with respect to this symmetric stretching and asymmetric stretching, one more important concept is there, that is parallel vibrations and perpendicular vibrations. So important topics is parallel vibrations and perpendicular vibrations. So what are the parallel vibrations? Parallel vibrations. So parallel vibrations means say this is symmetric to principal axis. This is symmetric to principal axis, we can say. And another what is say that before and after the movement of the molecules, the principal axis should be present. Means principal axis should not change during the movement of the molecules. I can say that principal axis do not change during movement or rotations of molecules. Rotations of movement, rotations or reflections or whatever. So the principal axis should not change during movements of molecules. Movement of molecules. Either if you are stretching or bending, it means IA during stretching or bending, principal axis should not change. Should not change. That is meant by parallel vibrations. And perpendicular vibrations is perpendicular vibrations. What I said that this is asymmetric to principal axis. Asymmetric to principal axis, and principal axis will change during movement of the molecules. During movement of the molecules. It means during stretching and bending, stretching and bending, stretching and bending, principal axis changes. That is called the perpendicular vibrations. And parallel vibrations means principal axis will not change. So we will take the examples and you will understand. Let's say if I am taking that, if H2O and CO2, if you check, let's say H2 is this type molecules, H1, H2, this is H1 and H2. Now if I am applying that, either I am applying bending or stretching, let's say now I will do that symmetric stretching. Symmetric stretching. And what I will do that, I will stretch this also. If I stretching this in the same, then I have also stretched it same amounts. So I will stretch this one H1, H2. So what you see here, the principal axis is C2, here also principal axis is present C2. Means if the principal axis is not changing during that bending or stretching, then this symmetric stretching or this stretching is parallel vibrations. So this is parallel vibrations. Similarly, if I take, let's say, water, and if I do that asymmetric stretching, let's say I'm doing that asymmetric stretching, then what, if I stretch this amount, and this one I'm stretching this directions, because I'm asymmetry means I stretching that molecules in different directions in a different amounts. So this is what I will get. Let's say H1 is here and H2 is here. So here what you see, that if this is the principal axis, then here principal axis is not there. Why that? What do you mean by that? Equivalent orientations means this C2 is not here. Equivalent orientation means in place of atoms, whenever I will rotate, I should get the same atoms. That is called equivalent orientations. And C2 means what? Whenever I rotate these molecules, but in place of atom, I should get one atoms. So if I do here that C2, then what I will get? H2 and H1. It means C2 axis is present here. Means in place of atoms has come. This H2 has come here H1. So that atoms, whether it's H1 or H2, but in place of atoms has come here. But whenever I do that here C2 axis, then what I will got here? Here I got that H2, here I got the H1. It means that here no atoms was there, but now atoms has come, and here atoms was there, now atoms is not there. So this is C2 axis is absent. So we have discussed in group theory that to presents any axis or any what is say that that rotations or that is what you say, that is reflections. So for that equivalent orientations is present, then that axis is present. But here whenever I do that rotations, then I'm not getting that equivalent orientations. So it means C2 axis is absent here, and the principal axis here is C2. So here principal axis is absent. It means this is perpendicular vibrations. This is not parallel vibration. This is perpendicular vibration. Means after stretching or bending, if you not get that C2 axis, the principal axis, then you will not. That is perpendicular vibrations. Similarly, if I take about of CO2, then COH like this. Okay, now I am doing that asymmetric stretching, or let's say asymmetric stretching. Symmetric stretching, if I do, then what I will stretch in the same directions, either this directions or these directions or these directions. Then whenever here that principal axis is, we know that I already discussed that principal axis is C infinity. Here also principal axis is C infinity, that we already discussed in group theory. So at principal axis C infinity. So whenever I do that stretching, then what I'll do in this case, what I'm getting, this is getting like this. Like this means symmetric means I will stretch in same directions in same amounts. So if I stretch this directions, I have also stretched in this direction. So I can say that equivalent. What I say that means I will stretch in such a direction so that we will get that equal amounts and in equal directions. So if I stretch this, then I have also stretched so that I will get that equal molecules in their in respective positions, in the relative positions. So here if we see, here also what we have, C infinity is there. The principal axis is C infinity. Here also principal axis is C infinity. It means this is parallel vibrations. So after stretching or bending, if we get the principal axis, whatever there in before, the same principal axis if you get, then that is called parallel vibrations. So here also parallel vibration is there. Here also same way, if I do the symmetric stretch, here also symmetric stretch I did, and then so here also principal axis is present. So this is also parallel vibrations. Now if I do that asymmetric stretching, then what I will get? Let's say I will do that asymmetric stretching. This is the molecules. Now I am doing that asymmetric stretching. So asymmetric stretching means I will stretch in a different amounts in different directions. Let's say I am stretching this directions, then another I am stretching this directions. So what I will get here? Here the principal axis is T infinity. So now after stretching also what I get? So this become this, and this has become like this. Like this. So now my question is whether I get principal axis. So again we see that here also C infinity is there. Means again C infinities we have. It means that asymmetric stretching also here parallel vibrations, because here that principal axis is C infinity, here also I get the principal axis is C infinity. So we are talking with respect to principal axis. So let's say here C2 is said, here C2 is present, but here C2 is not present. But C2 is not a principal axis here, C infinity is the principal axis. So we are talking with respect to principal axis. So after stretching or bending, if we get the principal axis, whatever there in previously the same principal axis if we get, then that is called, this is also parallel vibrations. Okay, so here asymmetric stretching also parallel vibrations. Now if I talk about of that bending, we discussed only about of the stretching. So let's discuss about of that bending. Okay, for bending also, if you take that, let's say for water, this is H1, H2. Now I am doing that symmetric bending. Symmetric bending if I do, then what I will bend this one, this direction, then I will also have to bend this directions. I think bending we have discussed this. We not discuss, we take that examples, we not discuss about of that parallel and perpendicular vibrations. So let's say this is bending, I am doing that symmetric bending. So what I will do here, this, suppose if I get H1 here, then H2 I am getting here. So here we see that here that principal axis is C2, here also principal axis is C2. Means whenever I am doing that symmetric bending, then I am getting that principal axis here is C2, here also principal axis is C2, means this is parallel vibrations. Again if I do that asymmetric bending, let's say asymmetric bending, H1, this is H2. Now I will do that asymmetric bending. Okay, so if I bend this directions and another I am bending this directions. So here the principal axis is C2. Now I am doing asymmetric bending. Asymmetric bending if I am doing, then what I will do here H. So I am stretching bending this directions. So this H1 will comes here, and H2 is somewhere like this. So you see that C2 axis here, what I said, let's say H1 is comes here and H2 is somewhere like this. So means what I would like to say that if this angle and this angle are, let's say 45 degree and 45 degree, then what we say that this Means asymmetric bending means what? I am bending in a different directions in a different amount. Let's say if it is a 40 degree, then this may be 50 degree, so that the I will not get that same in place of atoms. In the atoms I will not get. So this is also a perpendicular vibrations, because the principal axis means that. What do you mean by C2 is present or not? How will you check? Whenever I am doing C2, then in place of atoms I should get here H2, here H1 I should get. But whenever I do this here, if I apply that C2, then what I say that, let's say if I draw it in a nicely, so let's say this one is H1, this one is H1, and let's say this is H2. Now if I apply that C2 axis, then what I will get this one. Here I will get H1, but again H2 I will get here. Means in place of here the atoms is not there, and in place of atoms here atoms is not there, atoms has come here, means C2 axis is absent. So it means this is a perpendicular vibrations. This is perpendicular vibrations. So that symmetric bending is parallel vibrations here, and asymmetric bending is perpendicular vibrations here. Okay, so somewhere that you see that asymmetric also parallel vibrations, and symmetric, that is a parallel vibrations. So it does not say that asymmetric stretchings are always perpendicular vibrations and symmetric stretching are always parallel vibrations. Sometimes asymmetric stretching also parallel vibrations, although maximum time asymmetric stretchings are perpendicular vibrations. Okay, now if I do about of that, take about of that CO2. So if I doing that symmetric stretch, symmetric bending, if I do, then here we see that principal axis is C infinity. Now I am doing the symmetric bending. Then what I will do, means I will bend this one this directions, and again I will bend this one this directions. So what I will do, see OH comes here, OH comes here. So here what you say that here C2 also presents. Okay, so here that C infinity is not there, means principal axis is C infinity. Principal and C2 is also present, but C2 is not principal axis. C2 is not principal axis. So here principal axis C infinity is absent. Okay, but here C2 is present. Here if you say C2 is there, but we are talking with respect to the principal axis. So if principal axis is absent, then previously whatever the principal axis, after rotations or after stretching or bending, if that principal axis is absent, then this is perpendicular vibrations. So we are talking with respect to the principal axis. Okay, so here symmetric bending is a perpendicular vibrations. Similarly, if I go for if I talk about asymmetric bending, so here principal axis is infinity. I am doing that asymmetric bending. Asymmetric bending if I do, then suppose if I doing like this and if I doing like this, then what I will got, see what I getting like this. So here also you see that C infinity is not there. So this is also asymmetric, sorry, perpendicular vibrations. So what I understand that what we understand that if we sum up, what you say that there are two type of vibrations, that is perpendicular vibrations. perpendicular vibrations and others are parallel vibrations.